So we're facing this differential equation. Let's see what we have. First of all, it's first order, so it could either be a linear or with separable variables. Clearly it's not linear because we have y squared. So it must be with separation of variables. There's a sum, which could be a problem, but if we can factor something, and we can factor y squared. So once we do that, it becomes evident that this is an equation with separable variables. So let's go ahead and separate the variables. Now multiply both sides by dx and divide by y squared. But when I divide by something, I need to take care of the constant solutions. So I can only divide if y is non-zero. When y is equal to 0, that solves the original equation because I get 0 here and 0 here. So I should take that into account. I'm going to write it here. Y equals 0 is one solution to this differential equation. Now, once I exclude that case, I know that y is not 0, so I can divide by y squared. Okay, great. Now I separated the variables. Here everything is in terms of y, and here everything is in terms of x, so I can integrate both sides. And now I'm going to move over here. So this is 1 over y squared. It's going to integrate as a power. I'm going to rewrite it as y to negative 2 dy equals integral of x plus 1 dx. And now here, increase the exponent by 1 and divide by it. So we get minus y to minus 1 equals 1/2 x squared plus x plus a constant. It's enough to only add one constant here because if I add the sum of two constants, that would still be a constant. And here c can be any real number. Now, at this point, I have an implicit relation between y and x, so I should try to solve for y. First of all, change all the signs and realize that y to minus 1 is 1 over y. Here I should have minus c, but since c is allowed to be any number, then minus c is also any number. So I can still write it as a constant c. And now I have 1 over y is equal to this. So to solve for y, I just need to take the reciprocal, which is going to be the reciprocal of this whole thing. Be careful when you're dealing with these constants. This is a whole piece, so everything goes in the denominator like this. So what is the general solution? Well, it's all functions of this form for any value of the constant and the function constantly equal to 0. So this is the general solution. Notice that you would never get the function y equals 0 here for any value of the constant c, so you need to remember to add it, otherwise you're missing one.